Bismillah ar-Rahman ar-Rahim. This is lecture 8 on the calculation of the magnetic field inside a solenoid. This problem can be solved by using Ampere's law and by choosing a rectangular path such that one of its sides coincides with the z-axis and the other perpendicular to it along any radial line inside the cylinder. For a solenoid of radius a, the length of the radial path is ρ less than a. Okay. We first assume that the solenoid is infinitely long along the z-axis. We also need to modify the requirements of the Amperian path by requiring h to be either tangent to the path or portions of it, and or perpendicular to the path or portions of it. The other requirement is that h be constant. We have to show that we only have two components of h to agree with our choice of such a path. Since the current in the loops is phi directed, then by the Biot-Savart law, h cannot have a phi component because h is always perpendicular to the current. So only ρ and z components are possible. We know that since the solenoid is assumed infinite in z, then h will be independent of z, and any point along the z-axis will do as good, so we choose the point z equals 0. And we resort to the Biot-Savart law to show that we only have a z component of h, and that h ρ equals 0. So we take a general field point at z equals 0 inside the solenoid, so that r is the position vector of the field point is ρ a ρ, and ρ is less than a. The field at this point is due to superposition of the above half of the solenoid and the bottom half. So we only need to consider the contribution from two current loops, okay, one at z prime, the other at minus z prime. And it suffices to take two symmetrically placed current elements with r1 prime equal to a ρ plus z prime az, and r2 prime equal to a ρ minus z prime az, and the distance to the field point from the first element is r1, r minus r1 prime, and from the second one, r2 is r minus r2 prime. But here, the magnitude of the distance, r1 and r2 in the figure here, they are the same. Although in the figure they don't look the same, but actually they are equal. Okay. So if we substitute in the Biot-Savart law, we have the contributions from the two elements. dH1, it is IDL, which is IA d phi, times A phi cross R1, which is R minus R1 prime, and dH2 is IA d phi A phi cross R2, okay, both divided by 4 pi R cubed, which is the same distance. Okay. Now, because z prime and minus z prime are opposite here, then they will cancel out when we take the cross products, and if we combine dH1 and dH2, we will get dH equal to IA times A minus rho sine phi d phi times AZ divided by 2 pi R1 cubed. So the rho components cancel. We do not have we do not need to integrate the Biot-Savart law here to find Hz, okay? But since the solenoid is infinite in Z, okay, we will always calculate the same value for Hz regardless of Hz. So Hz is constant along a line parallel to the Z-axis. Hz equals constant at a distance rho from the Z-axis. We have previously shown that at any point on the axis of the solenoid, Hz is equal to K phi, the current density in amperes per meter, which is equal to Ni or Ni over L for a long solenoid of length L. So for the rectangular path of length small l and width rho, if we apply Ampere's law to the closed path, the portions of the path in the direction of rho drop to 0 because Hz is perpendicular to it. The dot product gives 0. And we only have, on the axis, we have K phi, Hz equals K phi, and for the other one, Hz is unknown, but the current enclosed in Ampere's law is equal to 0 here. There's no current enclosed inside the loop. So the result is that Hz is equal to K phi equal to Ni or Ni over L. This is true at all points in the cross-section independent of rho's. And this is a good approximation for a long solenoid with L much greater than the radius A. This technique of using the Biot-Savart law to determine the components of the field without integrating can also be used to calculate the magnetic field above an infinite current sheet. Okay. And the result is very simple, and we will come up with the same result as the one we find by integrating the Biot-Savart law.